Good morning. My name is Gokay and I am here to present my final project, which is the Christmas trees transportation, logistics, and cost. A brief overview of what we'll be going over today includes introduction, problem statement, mathematical formulation, the code, the results, the future work conclusion, references, and questions which you may have. The purpose of this project was to basically utilize the linear programming techniques to solve a real-world linear programming problem. The overall goal was to minimize the cost associated with transporting Christmas trees for a Christmas tree company. The problem statement in summary is basically an order for 6,000 trees from Portland, an order for 4,000 trees from Eugene, and the supply of Christmas trees. The company has 7,000 trees on its farm in Oregon City and 8,000 trees on its farm in Estacada, and the company has to fulfill those two orders from Portland and Eugene, and our goal is to find the minimum cost associated and the best or optimum logistic. So we let X equal the number of trees from Oregon City to Portland, Y Oregon City to Eugene, Z the farm in Estacada to Portland, and W Estacada to Eugene. The different coefficients of cost associated with each trip, for example, shipping a tree from Oregon City to Portland costs $50, is factored. All the orders as well is factored into the cost equation. We have a couple of constraints, which includes the order constraint, the supply constraints, the implied constraints, and all the constraints put together in terms of X and Y. In terms of the order constraint, we have two orders. We have one for Portland and one from Eugene. We do know that for the order constraints, we have an equality sign because we know the exact number of order. For Portland, it's 6,000 trees. However, there are two ways to fulfill that order, and that's X and Z. The same thing for Eugene. We have Y and W. The supply has an inequality sign because we do know the number of supply. However, we cannot go above that, and we do not know the exact combination of shipment or shipping of the number of trees that will fulfill the orders. So X and Y is less than or equal to 7,000, and the same thing for Estacada. These are our implied constraints, and solving in terms of X and Y provides us with all these constraints, which are solved using two methods. I use the graphical method and Matlab. The graphical method provides us with a feasible solution, and the reason we have a feasible solution is because all the constraints are satisfied. We do have a physical corner points as well from the graphical method. I also use Matlab, and this is an a super abbreviated version of my Matlab code. Now to the results. The graphical method provided us with feasible corner points, which we use to calculate the cost and the order decision variables. And the optimum solution value is $460,000, and that comes from fulfilling the entire order from Portland, from the farm in Oregon City, and fulfilling the entire Eugene order from the farm in Estacada. If we had split it up or just guessed, we could have incurred a whole lot of costs. Now we're going to ask ourselves, does our Matlab code match our graphical solution? First, this is the optimum point that provides us with the optimum solution. And yes, our Matlab code matches our graphical solution, which it should. I mean, as it should, because if I did everything correctly, the two methods should match. This problem could have been made way complicated in terms of future work by including more detailed resources like trucks and manpower, and including time and size of trees as variables. For example, I didn't factor in how many multiple trips the company has to make to fulfill that order, or if the company has to rent more trucks to fulfill the orders. We'll have to evaluate the costs associated with that. If we had 24-hour delivery versus a week delivery, we have to factor in the costs associated with that. And if you vary the size of the Christmas trees, 4-foot, 6-foot, 9-foot Christmas trees, you have to maximize the space in the truck and minimize the number of trips you have to make. So these are some things I would like to research in the future and evaluate. In conclusion, the linear programming problem was solved using two methods that match, graphical method and programming method, and the problem was visible and provided us with an optimum solution value. Sometimes there are no right or wrong choices, there are optimum choices. Do you have any questions for me? If you do not have any questions, thank you very much for listening. These are my references. If you do not have any questions for me, thank you very much for listening and do have a Merry Christmas. Thank you.